Every pineapple has a story, but too often, that story ends when the peel is discarded. We are pleased to present PineCycle Precision, a process-controlled pineapple peel cookie premix. This innovation was developed by Nur Shahidatun Naim Misran, Farah Nadia Kamarudin, Nuraihan Muhammad, and Jasni Muhammad Supandi from the Department of Culinary Arts, Management and Science University. Pineapple peel is commonly treated as a waste, even though it may still have potential as a food ingredient. Our project explores how freshly collected pineapple peel can be processed into flour and incorporated into a convenient cookie premix. The pineapple peel was collected from a small fruit stall on the same day that the fruit was peeled. Only fresh peel from the MD2 pineapple variety was used. For batch 1, the pineapple peel was trimmed, but the dried leaf material attached to the peel was not completely removed. The peel was washed using purine fruit and vegetable cleanser and then rinsed thoroughly with clean water according to the product instruction, ensuring that no clean residue remained. The excess water was drained before blanching. Each citric acid treatment group began with 3.79 kg of fresh pineapple peel, measured using the same weighing scale. The peel was blanched in boiling water and immediately transferred into ice water to stop further heating. Before blanching the next group, the water was returned to boiling temperature to maintain a consistent procedure. Blanching was included as a heat pretreatment, while the subsequent acid treatment was intended to help limit undesirable color changes. Heat and acid can both influence the enzyme involved in enzymatic broiling. 2 citric acid solutions were prepared, 0.5% and 1%. The citric acid was dissolved completely before the peel was immersed, so that the treatment solution was as uniform as possible. The peel was soaked for approximately 5 minutes, lightly rinsed and drained before drying. Batch 1 was dried at 55 degrees Celsius and reached the recorded drying endpoint after approximately 44 hours. Batch 2 followed the same general washing, blanching, citric treatment, rinsing and drying procedure. However, the dried leaf material was removed more thoroughly and the peel was cut into narrower pieces measuring approximately 4 cm by half a centimeter, using the same off-household dehydrator, the same temperature and the same initial peel mass for each treatment. Batch 2 reached the drying endpoint after approximately 28 hours. This was 16 hours faster, representing a descriptive reduction of 36.36%. However, energy savings cannot yet be claimed because electricity consumption was not measured. After drying, the sample was weighed to calculate dry recovery. The dried peel was then ground into coarse powder and milled 4 times to obtain a finer, more consistent flour texture. Each flour was weighed again after milling. This allowed us to calculate 2 important indicators. Flour yield shows how much finer flour was obtained from the initial fresh peel. Milling retention shows how much dry materials remain as usable flour after grinding and milling. Each flour was evaluated in 2 cookie formulations. The 50% pineapple peel flour formulation contained equal amounts of pineapple peel flour and wheat flour. The 100% pineapple peel flour formulation used pineapple peel flour as the sole flour component with no wheat flour added. A control cookie was also produced using 100% wheat flour. The ingredient and cookie portions were weighed carefully and the same mixing technique, oven temperature and baking duration were used. Every tray and sample was labeled to maintain traceability. Some differences in cookie output were recorded. However, the number of cookies may also have been affected by small inconsistencies in the portion weight before baking. Future trials will therefore use tighter portion weight control. The batch 1 treatment were coded A1 for 0.5 citric acid and A2 for 1% citric acid. The batch 2 treatment were coded B1 and B2 respectively. A1 achieved the highest flour yield at 8.71% and the highest milling retention at 95.65%. B2 produced the lightest flour, but it recorded the lowest flour yield at 7.92% and the lowest milling retention at 89.55%. These findings shows that lighter color alone is not enough to identify the best treatment. Within batch 2, the 1% treatment showed no clear flavor advantage, while B1 provided better flour recovery. Therefore, 0.5% citric acid was selected as the more practical provisional batch 2 treatment. This is the PineCycle Precision Premix prototype. Our next stage will validate laboratory analysis, instrumental texture and color measurement, structured consumer testing, production costing, packaging evaluation, and also shelf life assessment. PineCycle Precision transform pineapple peel from a discarded byproduct into a measurable, process-controlled premix concept with potential for education, community enterprise, and future commercial development. From peel to precision to possibility. Thank you.